All right, middle of the week. Everybody's starting to get tired, I know. A long week of content, but another session and a long one. So just so everybody knows, we go until 6 p.m. and I'm pretty much going to use every minute of my 90 minutes to really prove a lot of points. I took a lot of time on this topic because I get this argument all the time that disk space is cheap. Right? A lot of people hear that. Oh, who cares about an int versus a GUID? You know, 4 bytes, 16 bytes. You're talking about 12 bytes. That is so not interesting. What could you possibly say for 90 minutes about 12 little bytes? Just wait. I will be saying a lot more than just these 12 little bytes. And I'll show you actually the cost of these 12 little bytes in a whole bunch of different ways. And I think that's one of the things that's really important that sometimes we lose sight of. We tend to look at things very narrowly. We only look at one little aspect of some performance test or something, and we don't really get a good picture of everything that's going on, of everything that's happening, and of all the reasons why we should or shouldn't do something. So what I did for this session is go through every single aspect of what's interesting or uninteresting about GUIDs, and what I'm going to try to do is prove to you all the unbelievable number of places where GUIDs can really come back to haunt you. And then I'll give you a whole bunch of insight into things you can do. In fact, I'll give you probably 5 different solutions that some of you will be able to implement in different ways depending on your environment, depending on whether or not you can re-architect the system, depending on whether or not it's third-party software that you have no control over that uses these things and abuses these things horribly. You know, what are the solutions that you have? And I didn't put the slides yet because they're completely full of massive amounts of numbers, and I wanted to kind of surprise you with some of these numbers. I'll be loading them tonight, though, after the session, so they will be on the PASS site. You'll be able to download them and access them, so you will be able to get all these numbers, because you won't be able to remember all of them, and there's a lot of numbers. So this session, hopefully everybody's in the right place, right? Tales from the trenches, GUIDs, use, abuse, and how to move forward. These are incredibly common. As a consultant, as a trainer, I run into these all the time. And I would probably say in the last 3 or 4 years, I mean, they've been around even longer than that, but in the last 3 or 4 years, these have crept up into being one of the top 10 worst problems I deal with in terms of performance. And they are not easy in some cases to be able to clean up and fix. And so understanding how these are truly problematic is really important. So my name's Kimberly Tripp. I've been working with SQL for a long time, almost 20 years now actually. And for the last 15 I've been doing training consulting, speaking at conferences like this. And over, I'd say even the last 5 years, I've done even a lot more consulting than I even used to. But it's amazing what you can see out there. So I'm really, excited to show you guys a lot of these numbers and a lot of these scenarios. So I just thought I would point out, on SQL skills, we do post our demo scripts, and I will also be doing that as well. I'm not going to post every one of the demo databases I have, because then I'd be posting like 2 gig of stuff up there, but I'll post a lot of the code in terms of analyzing fragmentation, in terms of analyzing sizes, row structures, and so forth, and then I'll show you a lot of the scripts and demos that I'm doing as well. So you'll definitely have a lot of content that you'll be able to pull down from there, but I'm not going to dwell on this part. I want to get right into GUIDs. UUIDs, which is really the generic and starting point for the Microsoft GUID, these have been around for a while, and there's basically a standardized format for these. And the idea behind coming out with UUIDs and therefore GUIDs is that we can come up with a value programmatically without having to reconcile with a central authority. That's really the sole interesting thing behind a GUID. The likelihood of a duplicate is so darn low that most developers don't test for duplicates, don't even plan for duplicates, and know that they can pretty confidently, in a client, generate an ID, probably for parent rows, then have all the child rows, like let's say line items for some type of sale or orders table, and they know that since they've generated their order, all of their child rows can go off to the server as a single batch, and they don't have to reconcile with that central authority as to what the ID is. They're able to generate it on the client. And initially, I think a lot of people chose this to get rid of things like round trips. You know, they didn't want to go to the server to generate an ID, to then come back, do things, get the child row and child details, and then go back again to upload. So there's a lot of reasons why people use these, but the number one most common reason that I tend to find is the simplicity in the application design. It's almost always, let's not have to talk to anybody. I can just generate my numbers and I'm safe. So that's almost always the number one. In fact, you know, is that one of the reasons why some of you guys are using it? Okay, you guys are kind of quiet. Some of you are holding your hands down low, like, yeah, that's why I'm using it. I'll definitely give you some good solutions for that, but that is overwhelming. Like last week, I was at more of a developer-oriented conference, and I had like 80% of the room was just like, yeah, that's why we're doing it, right? And it's really, really, really the most common reason. There's other reasons. And talking about the likelihood of a duplicate for a second, my favorite line is actually this second one. If every human on Earth generated 600 million GUIDs, there would be only a 50% probability of a single duplicate among all those generated. Which is pretty unbelievable, right? I mean, that's a pretty incredible, you know, number. And the fact that we can do that so confidently is what allows us to create these applications where we don't have to reconcile. And I totally get the simplicity of it, right? We can essentially presume that no collisions will occur. We don't have to do any round trips. We don't have to write any, I don't really think of it as complicated code, but we don't have to write any code that goes on the server to have to kind of figure out IDs and have those IDs move down further through child rows and so forth. So it really does simplify things, okay? It sounds really good. I get that. I totally get that. The interesting thing, though, is it's really usually not a lot of code to actually figure out an ID if you do centralize those IDs, if you do generate them in a server. And you don't always have to generate a round trip to kind of go generate the ID, get the ID, bring it back, do more stuff, send the child rows over. You can often very easily generate the ID, trap that ID, and then use that ID all within that same batch with code that runs on the server. And that, in and of itself, can significantly improve the way that you generate and deal with these IDs. And I promise, numbers are coming up in a moment. One of the other reasons people use these, and I have to kind of squash this one a little bit, is that they're not predictable. Generally speaking, I would agree with that. I would also say they're not easily readable. They're not very pretty if you have to look at them. I mean, how many of you guys ever have tables like a sales table where the sales order number is a GUID, the customer number is a GUID, the product ID is a GUID, right? The salesperson ID is a GUID. I want to kill myself looking at this output. You know what I mean? Like, I'm trying to read this and it's like, it's impossible to read. So I'll give you that. They're not predictable. They tend to be a little bit less obvious. But it is true that with some clever analysis of the server and understanding the different types of GUIDs that are generating, specifically Microsoft's GUIDs, that if you use things like sequential GUIDs, they start to become incredibly predictable. So, you know, if people are going to argue the security side, there are certain aspects to that. But especially if any of you go to sequential, you lose all of that. So it's not something I would generally use from a security perspective. And I've definitely quoted a whole bunch of resources, and you guys can read a lot more about this if you want to see the exact format and how they're generated and all that good stuff. And I'm not going to talk about like the breakdown of each of the different structures or pieces of a GUID. You know, in the history or in the early days, it was generated based on MAC addresses. People actually claimed that that violated their personal security to use a MAC address. So now Windows has a component in it that generates a piece that's randomly generated. So there's all sorts of different interesting things you can learn about the structure. It's not what I'm going to talk about. I'm going to talk about the impact of having chosen to use these, which again, it's just 12 extra little bytes if you compare it with an int. So I'm going to compare it with an int and talk a lot about how it's chosen and how it tends to become a problem, not just with fragmentation. You know, I kind of struggled because I think a lot of folks probably think my session is nothing but fragmentation, because I think the number one thing that a lot of people run into with GUIDs is fragmented nightmares. But what I want to show you, and what I'm going to show you with my numbers, is that the problem is way bigger than that. Way, way bigger than that. And you'll see how really problematic it is, even if you don't use it for the clustering key. Okay, so there is a lot more to it than just fragmentation. But I'll start with that because that is, of course, why a lot of you are here, right? Usually, and sometimes Paul and I call, you know, these folks that design for SQL, but were never trained formally as a DBA, kind of involuntary DBAs. You know, they start to create databases. You know, SQL doesn't jump out and tell you that, you know, you have to know about primary keys and indexes to create databases. Right? It's so easy. You create a database, you create tables, you know, you learn about relational integrity even just a little bit, and you say, yeah, I need a primary key, and you start to say, oh, well, this is a key, it's unique, and you go ahead and you make it the primary key, and yet nobody tells you, and you often don't learn this till way down the road, that the way that SQL Server enforces that primary key, making sure that the rows are in fact unique, is that it uses a unique clustered index. And what also people don't realize is that now our table is ordered by that primary key, whatever it may be. And of course, if our primary key is something like a randomly generated GUID, it's almost as though you've just created the most perfect formula for fragmentation. And literally, you have. You can have, in some cases, only 10% churn, less than 10% churn on a data set, and yet have 100% fragmentation. So there's definitely problems, especially when the primary key is enforced, and it is by default with a unique clustered index. The note that I have at the bottom is really important. The primary key doesn't need to be clustered. Although again, a lot of people don't even know that they should be thinking about this and that they should deal with this and that they should change this. And then even just last week, somebody came back and said, well, okay, if I don't make my primary key clustered, aren't I going to have all these fragmentations in my non-clustered? Absolutely. But if you're not real familiar with internals, the clustered structure is the whole table. It's the widest structure, and it has the most restrictions on things like online operations. So the likelihood that you can rebuild the clustered regularly and keep the table online is a lot lower and a lot more challenging than a non-clustered. A non-clustered is usually a lot smaller, a lot easier to manage, a lot easier to maintain, and a lot easier to rebuild, and things like fill factor, which I will talk a little bit about, will go a lot longer of a way with your non-clustered indexes. And I'll come back to that. So yes, you're going to have fragmentation. Basically, the way I look at it, if you're going to have more than one index on your table, and even in some cases, even just one index on a table, you're going to have fragmentation. So even if you've fixed some of the problems with the clustered, you cannot fix all of the fragmentation problems with all of your indexes. So every database is going to need maintenance. Okay? Every database is going to need some form of maintenance. The other problem, and let's talk about this for a second, because I think this is actually very interesting. Every table's primary key is often referenced by foreign keys, which now let's just talk about that little size issue again, right? If we have an integer, then our foreign keys are only 4 bytes. But if we have a GUID, we now have 16 bytes, and then 16 bytes, and 16 bytes, and 16 bytes. And very likely, all of those things should be indexed as well. So my joins are 4 times more expensive than they need to be. And while your tables are small, you know what? Nobody notices this. But as the tables start to get large, I think you'll be amazed at how much space it starts to really take up and how expensive it really tends to be. So let me give you some numbers, some real numbers. I've got 3 different databases that I'm going to show you in demo with, and they all effectively do the same thing. I basically have a database that, very simply put, is customers, products, employees, and sales. And I have 3 different versions of that database, where one uses only integer-based numerics for all of the keys of all of the tables. I then have one that uses non-sequential GUIDs, just kind of simulating the .NET Framework's generation of your GUIDs using UUID in the back end. And then I've got one using sequential GUIDs. Now, of course, between the sequential and the non-sequential, the size of the keys is actually going to be the same. But what's really interesting, these numbers that you're looking at are the size of my sales table, the biggest table out of all of these, right? And then the row size that I end up having when I have a sales table that has an employee ID that's an int, a product ID that's an int, a customer ID that's an int, and a sales number that's an int. Turns out that the row size is only 27 bytes. But when I get to my GUID-based tables, because all of those columns are GUIDs, it's actually 75 bytes, right? So we're looking at a table that's 3 times the size. So it turns out in my database, the initial starting point where I'm going to start a lot of my demos from is a 6.7 million row table. Not even that wildly large, okay? 6.7 million rows. And you're going to see a series of tests that get us up to about 6.7 million rows. And I'll show you how I influence and tweak each test along the way and what the costs of all of the operations are along the way. But the first thing to notice is look at how much darn larger that database is. We're talking 24,000 pages versus 81 versus 64. So let me give you that in some real numbers and some ideas of why this is so much bigger, because this is a lot bigger of a database. The first thing you have to remember is that a table can either be a heap or a clustered table, right? And a heap structure uses something called a RID for the lookup ID. And just to give you some comparison in numbers, the RID is an 8-byte number. If you have a table which is clustered, then the lookup ID that goes into each non-clustered index on that table is going to be that GUID value. And at this point, you're looking at a 16-byte value. Whereas if we had chosen an int, it would be a 4-byte value. And again, you know, 4 versus 8 versus 16, a lot of people, they throw the this space is cheap card at me. But what I want you to think about is what happens when you have lots and lots of rows. So let me give you a little bit more insight. I decided to do the simple math of what the cost would be solely in the lookup key value overhead if we had a 10 million row table with 8 non-clustered indexes. And then I decided to try different key sizes, starting with a 4-byte key, 10,000 rows, 8 non-clustered indexes, about 300 meg would be used in overhead for the lookups. I know that those numbers are small, so let me bring it up a little bit higher. If I have an 8-byte key, it'd be 610. And of course, that's about double. That's pretty obvious, right? 12 bytes, 915. Again, fairly obvious. And 16, you know, we're looking at 1.2 gig just in the lookups of just the keys in just the non-clusters, just the internal overhead that SQL Server requires. I'm not even necessarily talking about how the indexes are being used and what you're doing with the indexes. I'm talking about just the internal overhead. And then again, people kind of argue, well, 300 meg, 1.2 gig, that's not so bad. So I decided to say, okay, that's only 10 million rows, 8 non-clustered indexes. What if we have a more interesting table? And I've seen this a lot. People always tell me, oh, well, sometimes I cluster for ranges. And they end up with some convoluted clustering key that might be 5, 6 columns and let's say 64 bytes. And I've seen this with sales types of tables too, where people end up with, you know, multiple columns as a natural key to try to come up with an identifier. So they end up with 5 or 6 columns, and they end up with something like 64 bytes. So check that out. From an int at 4.5 gig to over 70 gig of disk space just in the lookups. Those numbers are pretty scary, right? I mean, just to mention the internal overhead. And this is one of your tables that has, in this case, 100 million rows, 12 non-clustereds. I don't even think that's that far of an exaggeration for a lot of folks. Most people end up having, you know, 8, 10, 12 non-clustereds. What if you have 2 billion rows? I mean, think about how much, you know, 2 billion rows. I mean, that would be times 20, right? 100 million times 20. So 73 gig times 20. We're now talking like terabytes for internal overhead. That's terabytes on disk. Okay, disk space is cheap, but memory isn't. And remember that SQL Server reads these pages into cache. The more efficient your page is, the more efficient your memory utilization. The more efficient many of the operations you're going to be doing will be. And I'm going to show that in the numbers coming up. Question, comment, yeah. Yep.
You say lookups, you need the non-clustered indexes on disk space?
I'm talking, yes. So
In this case, the 12 non-clustered indexes are taking up 73 gigs.
oh, no, it's even worse. This is just the amount of space that's needed in the non-clustered indexes, not including the columns on which you're indexing, to do the lookups between the non-clustered and the base table. So yeah, no, so your indexes are going to be even bigger than this. This is just the overhead. Yeah. So a pretty scary number, right? I mean, this is literally just the internal overhead. Your indexes and whatever columns you're indexing on, they'll also need to be stored as well. So you could be looking at a huge amount in space. And having a clustering key that's inefficient really does make your non-clustered indexes less efficient. It makes your joins more expensive. It makes almost everything that goes hand in hand with that table and its operations more expensive. So I wanted to give you some numbers, in some cases some I think fairly shocking numbers, but what I really want to show you is what I think you guys care about more, because you might throw the disk space is cheap argument at me. What does it mean in terms of operations? What does it mean in terms of inserts? Because inserts, I would argue for your sales table, are at the core of your business, and you obviously want the inserts to be as scalable as possible so you can handle as many inserts as possible. So what I did is I created, like I said, 3 versions of the same database. One that was based on integers, one which was based on GUIDs that were non-sequential, random GUIDs, and one that were based on sequential. And you can see that just in the database size alone, my initial starting point of 6.7 million rows, we were looking at 334 meg versus a gig versus 961. I mean, pretty close for the GUID-based ones. But the point is we're already at only 6.7 million rows, 3 times the size in the database. And each of these tables, by the way, only has, I think, 2 indexes on average. Okay? So I didn't go crazy. Like, I could have made this database, you know, a lot worse, and I could have really tried to fudge the numbers to make it look bad. But I'm telling you, this is actually a reasonable starting point with only a few non-clustered indexes. Okay? So this was my interesting starting point. I rebuilt all the indexes with the default fill factor of 100% to give us a starting point, because some people think that rebuilding alone is good, and rebuilding can be good, but it can actually make things worse if you don't get it right. So I promise I'm going to come back to that. So I just went with the defaults. I rebuilt all the indexes. I made everything nice and compact, and then I started letting operations at these different databases. The other thing I also did is I decided, I wonder how well compression is going to do with these databases. And of course, you could expect the GUID database to not do so well with compression. But my point is, okay, you're arguing that disk space is cheap. I'm not saying you guys are, but I mean, that's my #1 argument, is disk space is cheap, right? But look at this. My integer-based database compresses down to 58 meg, whereas my GUID database, I'm just about 50%, 531 meg. Because those GUIDs aren't going to compress very well, right? Now, in the sequential-based GUIDs, I got extremely good compression that you guys probably wouldn't always expect to see, because a lot of my inserts were being done right in a row to all of the tables, and the way SQL generates sequential GUIDs is, and they're not really sequential, okay? They're pseudo-sequential. Let me explain. When you generate a GUID, SQL basically generates a base starting point value, and then it will generate up to 250,000 increasing base values, and then based on usually that range or some kind of time shift, SQL will reseed and do up to 250,000, and then reseed and do up to 250,000. The reason why I'm saying that is what you get is a pattern where they're increasing, and then they go back, and then they'll be increasing, and then they'll go back, and then they're increasing, and they'll go back. So you actually have a pseudo-sequential GUID that generally has 5 to 10% fragmentation, as opposed to random GUIDs, which are usually, and you'll see this in a moment, like 100% fragmented in a very small amount of churn. So sequential GUIDs are better, but they're not perfect, and I promise I'll come back to that. But I did get great compression with them because the pattern, that seed value, was so repetitive across all my tables that it compressed very well there. But still, you know, didn't get the same compression that I got with the ints. So that's kind of the first thing we're looking at. And if you're doing full backups regularly, you know, we're talking about 500 meg a day, a week, a month, right? As opposed to 58 meg. And depending on how many backups you have to keep, And I have customers that will keep their backups 10, 12 years, depending on legal requirements. That's a huge amount of disk space when you're talking 10 times the amount. Oh, and it gets worse. So let's get worse. What I'm going to do first, though, is I've got something that's going to take quite a bit of time to run. So I want to show you a few things before I start walking you through about 5 different scenarios that I did on other hardware in other environments and what their impacts were. But I want to show you what's going to happen on my machine, and then I'll summarize the results on this machine as well. So first of all, I've just re-restored my database on this machine, and you can see, I'll show you the code, it's not very exciting, but I basically can set which drive I'm going to restore to, and sometimes I'll do this to a USB drive for certain demos, sometimes I'll restore to an internal SSD drive, and just to give you some specs on my baby here, I love this laptop. It's a freaking 8.5-pound beast, but I've got 2 256 gig solid state drives, 16 gig of RAM, a quad core with hyper-threading, so it's impressive when you pull that up and you kind of go, wow, that's not bad. But it weighs 8.5 pounds, so it's kind of a workout in and of itself. So what I've done today is I took my backups and I've re-restored them on this machine for my SalesDB ints, my SalesDB GUIDs, and my SalesDB sequential GUIDs. And you can see all I'm doing is restoring those databases. And just to give you some insight, these are already databases where my read-write file groups consist of 2 files. And I'm not even going to talk about that here, but I do have to admit, one of the first things I do in most of my databases where I have a read-write intensive file group is I have at least 2 to 4 files. Not the same number as cores. I totally disagree with that crazy recommendation. But I usually do go with 2 to 4 as a starting point for the portion of my database where I'm heavily going to read-write. So these are already at that point. Okay, so I've got 2 data files for my read-write file group, and I've got that for every one of my databases, my SalesDB ints, my SalesDB GUIDs, and my SalesDB sequential GUIDs. They're all going to be on the same drive, which at this point is my D drive. And then I checked the count to make sure that all of the databases were in sync, right, to prove that I had exactly the same number of rows, same starting point. There's one difference, though, and that's seen in the fragmentation levels. And that's because I've actually already run a bunch of stuff against this database in tests that while this test is running, the one I'm about to start, I'm going to tell you how I built up to this version and environment. So we'll talk about the fragmentation in a little bit. But for right now, I'll show you what I'm going to do. It's not overly exciting, but it is interesting, right? I'm going to set a variable here of the number of rows I'm going to insert. I'm going to insert into each one of these databases, just very simply, 30,000. Then I'm going to go to the next database and do 30,000, and go to the next database and do 30,000, which sounds like an incredibly lame test, but you're going to be amazed and surprised at what we're going to see from it. So the way I do it as well is I go and I grab a random time, and then I've got some code that's exactly the same for every one of the tables to basically randomize the employee ID, the customer ID, and the product ID. And I've got that exact same code for every single environment. So there's nothing that's different in any of these. So they all have the same overhead for the randomization. Okay, so they all are doing exactly the same thing. And like I said, I'm just going to let it run. So we're going to let that, I'm just going to make sure that we have no errors, everything looks good. Okay, so now that's running. So now what I want to show you is what I did in setting up for what you've got. I started on a different machine. Okay, first of all, I started on a less powerful machine. I mean, I do have to admit, some problems can be killed with iron. Okay, and I'll actually show you where and what kind of iron you want to kill certain types of problems with. Okay, so I'm going to get to that too. But the one thing I did do that I didn't directly explain, and I'll tell you a little bit about this now, is I did have to add a small integer column to customers, employees, and products so that I could use getDate to grab random rows, because I can't predict GUIDs, right? I can't even predict random GUIDs of values that I have. So I put a small int so that across every table, I could use that to grab the values. But of course, when I insert, I put in the GUID, okay? But I'm doing it even in the integer-based database, okay? I'm doing exactly the same code in all 3 of the databases. And I started on a machine that was a dual-core 3 gig of memory. It was a laptop, and I was using an external USB drive, okay? Not a great combination, but the idea is, not super fast LUNs, and not all of your servers have great hardware, so let's start with that. I did the insert into the sales database on integers. It took a whopping 17 seconds. It was pretty fast. That's what we'd expect, right? I love this. You guys ready? Is everybody looking? I then did it in the random-based GUID database. Are you ready? Really? Oh, come on. I'm going to tell bad jokes all day. You guys, yeah, come on. Are you ready? No, all right. 5 freaking minutes. Come on. I didn't even expect that when I first wanted to set up this environment. I kind of was going, this is better than I thought it was going to be. This is really crappy, right? That's unbelievable. It's unbelievable. We're talking 17 seconds versus 5 minutes. Okay? Crummy hardware. I'll give you that. Okay? Crummy hardware. That is a factor. All right? I then did it with the sequential GUIDs. No fragmentation, but I still had a lot more time than the insert with the GUIDs. And I'll explain why. Okay? It's not fragmentation. So let me explain what ends up being the result of that particular environment. After the run, we end up seeing that our sales database that is integer-based, in terms of fragmentation, there's a little bit of fragmentation in the non-clustereds, but really virtually none here in our clustered. And in fact, there really isn't. The only fragmentation is just from the fact that SQL couldn't have all of the extents immediately next to each other. The next one, check this out. I had 6.7 million rows, and I only added 10,000 rows, and I have 22% fragmentation. Because effectively, every insert that came in hit a different page. So I've only got 73,000 pages, right? So at 10,000 rows, I'm hitting almost half of that table. Or not half, sorry. I'm hitting about a tenth of that, or a seventh of that table. And that's what's getting me, just massive fragmentation. This is why some of you can have not even that much churn. 10%, like 10%, what would 10% have been? So 6.7 million rows, 10% would have been 670,000. I inserted 10,000. So I inserted like 1/7 of 1%, and I got 22% fragmentation. Think about that. Even 1% of your data, you could end up with 100% fragmentation. Which is why if some of you guys are rebuilding tables that have GUIDs and rebuilding them with the default fill factor, you are actually doing yourself a major disservice. Because you are creating worse performance, not better performance. Because when you rebuild with that default fill factor of 100%, you fill all the pages to 100% full. So every single insert immediately after that is just splitting like mad. If you don't use a fill factor, you are making your performance worse, not better. And you're sacrificing all this overhead in doing the rebuilds. So that's an important point, and I promise I'm still going to come back to that. And that's really why these numbers are so bad. Now down in the sequential, interestingly, I have even less fragmentation than I have in the integer-based one, which is what I would expect, because all the key values have the same seed. So I'm actually getting massive contiguous inserts across every one of my tables for the most part. They're all sequential. So that's actually why this one has even less. It's going to turn out I'm not going to recommend that you move to sequential. Maybe if you have no other choice and you have to use a GUID, maybe you can move to some sequential, but you're going to still find out that there's still more issues, and I promise there's a lot more to show you. Yeah?
Is the integer-based key not sequential, not an identity column?
No, so in this particular case, the integer-based column is sequential, just like this guy is sequential. And that's why we have no fragmentation here in the leaf level, and no fragmentation here. Sorry, let me tell you exactly what you're looking at. This is the primary key, and these are all the leaf levels of the indexes. These are 2 other indexes that are foreign keys, so each new sale, each customer has to go into that index. That's why those indexes are definitely going to have fragmentation. It's just down here, every single row I insert is grabbing a randomly generated GUID, but they all have essentially the same seed, so I have virtually no fragmentation down here. That's usually not how it's going to work in the real world, though. It's just because I only have a few 100,000 rows, right? Or I have a few million, but my seed, the number of seeds I have is very small for this, okay? So I did it again. I said, okay, we've now got a baseline, cache is warmed up, let's see if we get some gains now. So I did the same thing. I didn't change anything except I just did 10,000 more inserts, okay? And it took about 24 seconds. And the other one was like 17. I mean, that's kind of almost a rounding error. I mean, that's not that big of a difference. Very fast in general. And the GUIDs was now up to 7 minutes. Just wait. It actually gets significantly worse. The sequential GUID, about the same. So the sequential values right now are trending about the same, and that's what I would generally expect because they're not going to be having as much fragmentation. And I would say that a lot of these problems are caused by fragmentation. But wait, I'm going to get rid of the fragmentation problem and show you that there's still other problems. Okay? So look at my fragmentation at this point, right? I did 10,000 more rows and I still have another, 15% or so fragmentation. The other ones are still trending with not much, a little bit in the non-clustereds, a little bit in the non-clustereds, but the clustered, right, is really the one that's giving me the difference, especially in the non-sequential GUIDs. Okay, so at this point, fragmentation really seems like the problem, right? Fragmentation almost exclusively seems like the problem. But in fact, there is a little bit more to it, okay? So I then did it again, okay? And I promise there's going to be more. But I did it again, and I've done it a couple of times, and I wanted to make sure that I had a couple of values for you to see. So this one I actually did, then I re-restored the database, and then I did it again, just to see if we had really consistent, so we didn't get, have any strange anomalies as well. So I was actually now doing things multiple times just to make sure I wasn't kind of going crazy, because the numbers were getting scary, right? So that one took about 24, 25 seconds, right? I then did the GUID-based database, and we're now over 10 minutes. A little bit of a difference there, though. I was kind of interested by that I had 30 seconds of a difference, but in 10 minutes could have been anything that could have changed some of those kind of anomalies, but still pretty consistently horrible, right? And the sequential GUID, minute 12, a minute 9, okay, consistent. So the sequential ones are definitely trending very consistently. The random GUID, not so much, okay? I mean, it's consistent, but very, very bad. So then I looked at fragmentation again and I said, okay, if fragmentation is the big problem, let's fix that, right? Let's do maintenance. Let's rebuild. That is going to be one of the #1 recommendations I'm going to have for you, especially on systems where you cannot change the code, where you don't own it, where you can't re-architect it. And I'll show you how we kind of maybe lower some of these numbers. So that's actually what I did. I actually rebuilt these using the Books Online sample. Okay? There's a Books Online sample. I think I actually put it in here. Yeah. There's a Books Online sample that's under the DMV, and I've got a link to it at the end of the section, at the end of the slides, so you definitely will have that. But there's a Books Online sample under the DMV, DMDB index physical stats, that you can query that, which is actually how I was getting this information, okay? So I can query that, and then programmatically, if my fragmentation is less than 10%, SQL does nothing. If it's between 10 and 30, SQL does a reorganize. And if it's over 30% fragmented, it does a rebuild. However, there is a caveat that when I first looked at that code a while back, I went, oh, this is interesting. That code, that sample, rebuilds with the default fill factor, or I should say with whatever the fill factor was the last time you rebuilt, which if you've never set a fill factor anywhere, will be 100%. Which means you might leverage that code, which seems helpful, but you're going to rebuild with 100% fill factor. So I changed it, right? I changed it so that instead I would end up rebuilding with a fill factor of 90%. So I changed it, and I actually got this. In other words, I looped through every single partition of every table. That's what the code does. And for every partition that was over 30% fragmented, it would go and rebuild, and then it kind of spits out at the end what statements it executed. So you can see that I did have a table my products table had a little bit of fragmentation, but it's such a small table that the rebuild and the maintenance didn't cost me much of anything. Then I did this against my GUID-based database. So just to make the point, right? You say this space is cheap, but now your maintenance operations, and again, this was only in my one little database that's a few hundred meg, right, or a gig, let's say. It's not even a full gig or so of data. It took 7 minutes, 51 seconds. So now your maintenance operations are taking time, and what are they also taking? Log space, right? And then if you're doing things like database mirroring, you now have to send all that crud over the network, right? I mean, I've had customers that had database mirroring set up and were really happy with it, but ended up having problems during maintenance because their network couldn't handle the load of the maintenance flood of all the operations going across. And it was so bad that they were then generating network errors in their error log, and then it was breaking their mirror. They had tested their production load, and they were happy with the performance, but they hadn't tested their maintenance load, and then it was essentially breaking their mirror. So my point is, we do have to think about this stuff. If I don't want or have to do that much maintenance, I can end up saving myself a lot of time and a lot of resources. Plus, if your database has lobs, and it's your tables that have lobs that are fragmented, the worst problem is the only type of rebuild you're going to be able to do is an offline rebuild, which is going to then cause you downtime. And I know a lot of products that do that. I'm not going to name names. I know why some of you are here. It's not just SharePoint. Not that I meant to name a name, but I know you're all thinking it, okay? But they definitely have not just a lot of GUIDs, but a lot of tables that have a lot of lobs. And in fact, one of the big bummers, right, is even if you're going to go and do maintenance, you're going to take an impact to your availability while you're doing it. So that's a big bummer, right? A really big bummer. So everything else stayed the same. So at that point, looking at fragmentation, the only database that really had big changes was obviously the one that had the most fragmentation. So looking at the GUID-based database before I did the rebuild, we're looking at a page density of only 72%, 87,000 pages, 44% fragmented. We dropped the fragmentation to pretty much nothing, right, to 0. But the page density is only 90% because I said exactly that. That's what fill factor does. Pick up this table, duplicate it, sort it out, and when you put those pages and that data down, only fill those pages to 90%. Okay? So now things are looking better. It looks like I'll be able to sustain my inserts and I won't be causing so much fragmentation. I won't be causing so much splitting. And in fact, check it out. By having gotten rid of the fragmentation, my tables, if you look at actually the number of pages between these two as well as the number of pages between these two, because both of those were rebuilt because they had fragmentation more than 30%, I actually got 215 meg of disk space back, right? Or I should say of space within the database. The database itself didn't shrink, and I don't recommend shrinking it if I'm going to use that space. Okay, but at least I've got 215 meg inside the database, which now means less memory is going to be required, and if I do a backup, the backup would be smaller. Speaking of which, I actually did that as well. I've got some numbers on backups. So then I rebuilt and I did my loads again, and at least, right, we're back down to about the 5-minute mark, right? And it's going to turn out now it's going to be pretty consistent at about the 5-minute mark. But not a stunning improvement, you know? It was kind of back to where we started. And the sequential GUIDs really wasn't changed much at all, but I didn't end up doing much there either, right? And same thing with the integer-based database. Nothing really changed in those two, okay? So my problem can certainly be stabilized and minimized with certain hardware, right? With maintenance. There's no doubt about it. That's absolutely important. What I then did, right? You saw my numbers. I want to show you one other thing, and that's the page density after, right? The page density before, 90.3, now it's 90.4, 90.2 versus 90.1. You know, now that I have loaded 10,000 more rows, my pages are just a little bit more full. But what does that mean, right? I have a lot of time for inserts to come in before I'm going to start splitting again, which is good. but it does mean that maintenance is obviously going to be an ongoing thing. I'm going to have to rebuild again sometime in the not too distant future. As far as backups, let me show you a few numbers here because I thought this was pretty amazing as well. This first backup, I know the fonts are small here, I'll blow this up in a second, but at the very top, my first note here, this first backup I did when I had done 10,000 rows inserted, and then I did a backup which was before the rebuild. And the things I want you to notice, right, is that I had a 5.8, whatever, 3 or 4, 2, I guess, 5.82, 58.2 meg database, and I went up by half a meg in the integer-based database, and it took 16 seconds, okay? Whereas down here, I love this, I inserted 20,000 rows, and my database backup, which was 531, went up 73 meg to 614. Because even with compression, because of all that fragmentation, SQL's unable to compress those pages all that well, and we have a lot more pages, so our database really blew up here, right, even in our backup. So our backups are now more than 10 times. They were 10 times at first, but now they're going to be more than 10 times. And over the course of a few days or weeks, they could actually be 15 or 20 times the size of that integer-based database's backup, which is pretty amazing and a very scary number from a cost perspective. Okay? And that one took 76 minutes because, again, if it's larger, if we're not getting as good of compression, then obviously it's going to take longer to back up as well. So we're paying a penalty in so many ways, right? So, unbelievable. And this bottom one was 100 meg. It was my sequential, which was a very small gain again because of the unbelievable repetition in the GUIDs, a really good compression amount, pretty much in line with the integer-based ones, but still, because it's a bigger database, took 40 seconds. Okay? And again, you guys will have all these numbers to look back at. I just think it's really interesting when we look at more than just the insert. You know, our inserts are slower, our disk spaces were, worse, right? Our memory and our impact and the amount of memory we really need to do well with this is more. So we have this compounded effect across every operation you do. There was a question, comment, yeah. So great question. Let me show you the backup after the rebuild just to prove the point. With the fill factor, I had fewer overall pages because the splits were actually worse than the fill factor, and I kept my table more contiguous. But the question, would I maybe even want to go with a lower fill factor? If I'm not going to be able to rebuild again for quite some time, maybe because of the hit to availability, and maybe I can only rebuild once a week, what I would look at, and I do have some slides on this, is how fragmented you become between whatever is your rebuild schedule. And if you become very fragmented, then you might want to lower your fill factor. But if you don't, you might actually want to up that fill factor to keep your tables even more compact and waste less free space, which would then make your databases smaller and more manageable, and you'll have less of a cache footprint as well. So your whole setting, like how do I set fill factor, it's really frustrating. I agree with you guys because it's one of these questions. I can't believe I've gone 45 minutes without saying it depends. I think that's a record, right? But it really does depend. Each table, each index, and also not every index is going to be fragmented. So we have to actually worry. And for me, I actually specifically set my fill factors for my monsters. My top 6, 8, 10 tables. I mean, yeah, we have hundreds of tables. I don't care about 90% of them. I mean, we can name our most problematic tables almost like swear words at our offices, right? That darn table again, we all know what those tables are. Those are the ones I'm worrying about, and those are the ones where I will often micromanage my fill factor and really try to come up with the right fill factor based on my rebuild frequency. It's a great question. So let me continue on because things will get better, I promise, okay? That first scenario was fill factor, right? The second thing I did, which should be already impressive, you probably already have started to look at my numbers here, but the second scenario, I actually had the same machine, the same memory, so it was a dual core with 3 gig of memory, but I moved everything off of the slower hard drives and I put them on an internal solid state. Again, it still wasn't this machine yet, okay? But I put them on solid state, and I think it's pretty impressive. Fragmentation is no longer my only problem. I clearly have something else that's really making the discrepancy between the integer, which has dropped now to 4 seconds for 10,000 rows. I mean, talk about like no problem with scalability at this point. You know what I mean? We could throw a heck of a lot more at this, and they're going to be able to do just fine. But our GUID databases, their problem is no longer fragmentation, but it's now just the sheer size of the row, the requirement on cache, right? The size of the indexes, because remember when you insert into the base table, that has to be inserted into every non-clustered index. So ultimately, we're starting to bring together the sequential and the random to a very close number if we take care of the fragmentation and we throw something like hardware at it. Now, solid state, enterprise class solid state is not cheap. But I would tell you, especially for some of you that have third-party apps where you cannot change the application, might actually be a not too bad idea to consider solid state for the data portions of those databases that are going crazy with GUIDs. You still need maintenance, but you might actually alleviate some of your problems with solid state. And again, I don't get kickbacks from any vendors. We have some hard drives from Fusion IO that we've done testing on. No kickbacks, no nothing. I could care less. I'm just showing you numbers. And that case, those were just laptop solid states. Those weren't even, enterprise storage solid state drives. So huge gains. And just to make another note, I did another test where I rebuilt with 100% fill factor just to see what the solid state would do for me with the fragmentation, right? And there it was about 1:47, I think. So a little bit under 2 minutes, but from 5 minutes, still huge, even with massive fragmentation. So I have to tell you that killing it with iron might actually be an okay solution, except for the expense, right, to solve the problem, since you might not have any other option. Of course, maintenance is going to help, though, too. And the combination, you see, brings it down almost to the sequential GUIDs, which now is implying our performance is solely tied to size, right? The size of the records, because the records are the same in both of these cases. The records for the non-clustered are the same in both of these cases. This one might get a little bit of an advantage because of the non-clustered being sequential as well. And that's why we might have a 101 versus 114. But then I put it on this bad boy, right? I put it on a better machine. And I know some of you guys do kill your problems by getting completely new hardware. And that can sometimes be a good thing too, especially with things like solid state, more memory, faster CPUs, more CPUs. A lot of those things can add up. And I'll start to show you the impact of that with my machine right now. It should be done by now, although my hard drive light's still flashing. Good. Okay, so remember, I did 30,000 rows inserted, and even for my integer database, I'm only up to 12 seconds. Okay? 30,000 rows, 12 seconds. And that's, again, on this machine, much, much faster. These guys are pretty much in a dead heat, right? I mean, 248, 245, so we're looking at 4 minutes, so 240, so 4 minutes, 8 seconds, and 4 minutes, 5 seconds, 4 minutes, 6, really, if we round. So, to be honest, these numbers, I mean, I'll take these so that if you want them in your slide for today, you'll have them, because I wanted to make sure that you had them. I'm just going to paste the number itself, okay? And that's in milliseconds, okay? So, you know what I'll do? Before I save this up, I'll convert it to minutes and seconds. But you can still see how darn close these numbers are. And you can see that what I'm getting is, again, just the benefit of solid state, more memory, more CPUs, lots of gains here. But I'm telling you, you could do so much better with integers. You could do so much better and be a lot more scalable, and that database will last you a heck of a lot longer with those integers. I mean, even with solid state, even with throwing a much bigger machine at it, it's nowhere near the numbers for the integers. Nowhere near. And I mean, you can't, that doesn't lie, I mean, I swear to God, I'm not fudging these numbers. These only have 2 non-clustereds. If I had more non-clusters, it would have been worse. Okay? So GUIDs affect the size of your tables, the size of your indexes, the size of your cache, and the amount of cache that's going to be required. Think about that too. I didn't even mention this, but with an ever-increasing pattern, the number of pages that you're actually touching per the number of rows is really small because you're inserting 20, 30, 100 rows on one page before you need another page. But with GUIDs, one page, one page, one page, one page, one page, one. For every insert, you're going to effectively need that whole darn table in cache in no time at all. And if you think of like a sales table, you probably aren't looking at sales that are older than the last few months. So to be putting the last 5 years worth of sales into cache, it's killing you in your really big tables. This is one of the worst things you could be doing to yourself because that, no matter how much you can tell me disk space is cheap, memory is not. And I would bet money on the fact that no more than maybe 1 or 2 of you has half a terabyte of RAM. How many of you have half a terabyte of RAM? Is Thomas in here? Okay, 1. All right. How about 256 gig? Couple? Okay, a couple. But I would bet money on the fact that almost everybody is in the 64 or less with a spattering of 128s now. I'm seeing a lot more 128s these days. Okay, 128, spattering. 64 or less, everybody else, right? So if we're starting to talk about a 6 million row table that's taking gigabytes, right? And we don't have gigabytes and we have hundreds of millions of rows tables with indexes, we are killing our cache, which is why you guys are all disk bound. How many of you guys have I/O problems? It's because SQL can't put everything in cache, right? It's marshalling data in cache, pushing other stuff out, and then you're like, no, I need that. And you're just constantly throwing stuff out of cache. You're unable to keep the important data in cache for very long because these tables are just forcing you to touch every single page, okay? And I'm supposed to remind you guys that we go till 6, okay? So just a reminder, we're at about 5:30 here, so we've still got about half an hour. Half an hour of suffering, okay? But more numbers, okay? So I'll definitely give you even some more interesting things here. But size of cache, larger cache required, size of backup you guys saw, and then of course the performance of everything above. Your joins are not as efficient. Your manageability means you have to do more maintenance, expensive maintenance. And I mean, I didn't even have room to start mentioning things like the transaction log, database mirroring, log shipping, backups, cost of hard drives, storage, blah, blah, blah. And I didn't even mention this one, which, you know, is not something I've run into, but I had somebody tell me that they had to do some sorting with some GUIDs in the client, and they found that, was that you, Joe? Yeah. So they found that the way that .NET sorts is actually different than the way that SQL sorts, and the end result is that they were then bringing data down and having to either resort it or do different things on the server. Nightmare. And I don't even know all the details, but I do have some links that I'm going to zip into the scripts that I put up on SQL Skills. So if you guys want to read into that, there's like 3 blog posts and little tips and tricks that will help you out with that. But my point is, we have lots of problems with GUIDs. I mean, they were kind of touted as the, you know, end-all, be-all, don't have to worry about anything kind of number, but they've really come back to bite us really badly. Really, really badly. Yeah. Am I convincing you guys yet? Yeah. That's the whole rest of the session. I'm going to walk you through the things that you can do, some of which might be staged. You know, you can do one thing, then something else, and maybe slowly start to move away from the problem. But I'll definitely give you things that you can do right away, and then things that might take you a little bit longer, and things that are going to vary based on whether or not you're a server which is your own architecture versus something where you're managing somebody else's architecture where you cannot change the code. So that's the whole rest of the session. So, well, yeah, we're going to talk about that. Yeah, we'll go through a bunch of different solutions. Yeah, so give me a minute on that one. Okay, so, I mean, have I started to convince a few of you? Yeah? Yeah, one more question, then I want to move on. Say that again.
I don't understand about sequential
Oh yeah, absolutely. Oh, absolutely, and I'll talk about the central authority. So just to repeat the question here, the question was, you know, I don't really understand how sequential GUIDs can replace non-sequential GUIDs. They really can't if the way that you're using GUIDs is to not talk to a centralized authority. So I agree with you there. I'm going to give you a better way if you have to talk to a centralized authority. I wouldn't use the sequential GUIDs. All I was trying to show with the numbers is that sequential GUIDs actually, to a point, don't even help you anymore because your problem is not just the randomness and the fragmentation, but just the sheer size and cost of the GUID. So all I was trying to do really is convince people that a switch to sequential, if they are reconciling on a central server authority, is still not even the best solution. Great point. Okay, so first thing I would say is sometimes people throw GUIDs at me because they say an identity value isn't big enough because they think of an integer being 2 billion, right? And they think, well, what if I run out? And I get that. But you could go with a big int, which is a pretty darn large number. I have no idea what that is. You could go with a decimal numeric, right? With a scale, a precision of up to 38 and a scale of 0. It has to be a whole number. And I remember sitting down one day and going, I wonder what number that actually is. So I figured it out, and this is probably more than anyone needs. I mean, if any of you guys have a table like that, I'll do free consulting for you. I want to see it. Okay? I mean, if you have a table that needs a decimal 38, 0, cool. Oh no. It's just in case. So this is what got people in. Well, this is what's gotten a lot of people into a lot of trouble too. The whole, I chose 38, 0 because I wasn't sure. I wanted to have a number that was just in case big enough. And I get that, but be really careful because a 38, 0 is 17 bytes of storage fixed width, which is now going to be in all of your non-clustereds as well. In some cases, you might want to just go to the earlier breakpoint of a precision of 28. I mean, I would use the maximum in that breakdown, but it's 13 bytes with up to 28 digits, which is 10 to the 28, which is still a pretty darn large number. But to be honest, I usually find that big int does it for most folks. 2 to the 63 minus 1 is a pretty darn large number. But I only wanted to make the point that you could use a decimal if you had to, but be careful because those are really expensive, again, in terms of storage. In fact, I sat down one day just to figure this out. It actually took me a while to figure this out, but it's 99, and I don't even know how to say it, undecillion? Undecillion? I'm not sure. It's a big number, all right? So my point is if you really need it, you know, it's there. But I haven't yet hit any server that's come anywhere close to this, to be honest. And I have to admit another thing, though, too, without even going very far. I would never let a table get anywhere close to this. Because one of the things, and this is tangential, but I want to make the point, one of the things that SQL Server still, and probably for a few versions in the future, does not do as well at as I wish they would, and that's statistics. And I'm telling you, as you start to get tables that are in the hundreds of millions or billions of rows, your stats are going to stink. And I don't let tables get that large. I had somebody come to me once that said, Kim, I have a really large table. And I always laugh when people say that because, you know, I'm like, well, what do they think is really large, right? They said, I have a 3 terabyte table. Not database, table. And it turned out to be 20 years of their policy insurance information all in one table. Yes, it was partitioned, but yay, it was a heap. And ultimately, they wanted to build a clustered index on it, which sounds like a good idea, yes, but you take a 3 terabyte table and build a clustered index on it. SQL has to copy that, 3 terabytes, log it, 3 terabytes, sort space, almost 1 terabyte, 10 terabytes to rebuild that heap as a cluster. Now, I came up with a solution that's way better than that because it was partitioned. I kind of switched out, built, switched out, built, switched out, and I built them into another partition scheme. So there are things you can do. There are workarounds. My point, though, is one of the big problems they were having, if you have all that in one table, is you have statistics only up to 200 steps for all those rows. And I'm telling you, if you have any skew, any weird skew in your data, if your data is not perfectly evenly distributed, which whose data is, right, then you're going to have problems with stats. I never let tables, even partitioned ones, get anywhere close to that. I usually have tables by year. That's usually my cut point. I usually won't have years and years worth of sales. I'll have a new sales table for each year, and I will union those in a view, and I will often create a hybrid of partition views and partition tables. That's a bit outside the scope. I'm willing to talk about this at the end. But my point is, I would never, ever let this happen. I just would not even come close to letting this happen. So I just wanted to make the point that if you think that you need a GUID because you need this really large number, you don't. There are other options. And ultimately, what I want you to consider is maybe switching to some type of numeric. Okay? And preferably one that's smaller than a GUID, like an int or a big int is more ideal. But if you have to, you can certainly go with these and you can get an ever-increasing pattern. But as you get to the 38,0, 17 bytes is going to be just as much storage as a GUID, which means your performance is actually going to start to go down as well, so because of all that extra overhead. So remember, we didn't only have a problem with fragmentation. Our other problem was size. So we do want to think about that. All right. Now, I've already started with this and why we chose GUIDs. You know, laziness, simplicity. I mean, we're all lazy. We're programmers, right? They're kind of hand in hand. That's why we're good programmers. We like to automate things. We like to program it. We like to make it do the work, not us, right? So I get that. And it can make sense in some distributed or disconnected applications, security to a point, as I mentioned earlier. And I do understand that, but it doesn't necessarily have to be the primary key of every one of your tables, and certainly not the clustering key. Okay, and I think I've proven that point. The clustering key and the primary key do not have to be the same. That's one of the first things that you might and hopefully can change if you own the app. If you don't own the app, then you're going to have to do some other things. So what did people do before GUIDs? Identities. And I do have to tell you that you might actually be using GUIDs because one of your developers got burned by GUID or by identities. And I just wanted to make the point that there were a whole bunch of bugs early on in 6.5 and 7.0 when identities first came out, where they could have seeding problems, where if the server crashed, when the server came back up, it would think the identity value was lower than it really was, and it'd try to insert, but then you probably had a constraint, so then you get errors. They fixed that a long time ago. They actually now, when you start inserting with identities, they grab actually a chunk of identities, they set the value on disk higher than where you're at, and then they use those, and then they chunk it again. So that there might be a gap if the server crashes, but you won't ever have that problem where it goes to some value that you've already got. So they've actually done a whole bunch of stuff to fix that. And the other problem is that it wasn't even until SQL 2000 where you could actually scope your identity values correctly. And I do want to show you a little bit on that. But the point is, if you can switch to this, then I would, and I can do it without having an extra round trip, right? The problem, though, is usually with parent-child relationships, where when you insert into the parent, there might be a trigger that then does something somewhere else. Well, what's going to end up happening there is you might get the wrong identity if you don't scope it properly. And I just want to show you this. I have a demo script. It's not going to take me all too long, and I definitely want you to look at it and possibly play with this if it's new to you, for sure. And I guess some of you probably know this a little bit, but I've got a database called Identity Scope. I'm going to recreate it if it's not there. I'm not putting much in it. This is not a great way to create a database, but for a little sample demo one, it's okay. So I'm going to use my identity scope, and then I'm going to create this little data modification log. So it's just a table where I'm going to keep track of all inserts, updates, and deletes that occur, and just kind of log it. Okay, so a little bit of an auditing table, and I'm just doing this to prove the point. I'm auditing with a trigger. Okay, so there's my data modification table, and then I'm going to create a parent table, which is not very exciting. I'm just going to get an ID and a date. That's it. Okay, an ID and a date. But for every row that I insert, update, or delete, notice I'm going to take the values that I'm inputting and I'm going to put them into my data modification log table. So I'm going to, did I actually create that? Hold on. No, I created the table, but I didn't create my triggers. Okay, so I'm going to create my triggers. See, this is why I have my output for me, so I can keep myself honest. But there we go. So I've just created my 3 triggers. So if I just insert a simple single row, did I not create that table? Yeah, duh. Oh, so the triggers failed too, and I didn't even notice it. Duh. All right, keeping me honest. All right, there we go. I was like, oh my God, my demo failed. All right, so select star from test ID parent and data modification table. So there's my 1 row in my parent. There's the 1 row logged inside of my data modification log. So now everything seems okay, right? If we're not doing too much with this, we're kind of like, okay, that looks good. So now we're going to have our child rows, and our child rows is also going to have, I'm going to make sure I select this time, it's 3 triggers. And then, if I declare a parent ID by inserting and grabbing added identity, and then I insert my child rows based on that identity, we're going to go look, and here's what's interesting. The second row, right, has the right parent ID for all the child rows. To be honest, everything's looking really good right now. Okay? And you can even see all 5 of the rows, parent row 1, parent row 2, child rows 1, 2, 3. Everything's looking good. But I got lucky. I got lucky because my second parent row was also my second log row, which is actually where these values got their parent ID. My next log row is row 6, right? So if I go and insert another parent row, grabbing added identity, and I'll just go straight to the parent-child tables, you can see that my children of this third insert have completely the wrong parent because I grabbed the added identity, which is always the last identity value generated on your session. And can you imagine somebody coding this and not knowing because their first few tests went fine? I've seen that. It is not a fun place to be. Because now they've got to figure out exactly where and how all those rows went completely foobar. Yeah.
Or better yet, they coded it before the triggers were there, and then some of the triggers afterwards.
Or even worse, they coded it, the application, I'm repeating the comment, it's a great comment. They coded it, everything was working, life was good, life was good, life was good. Somebody said, let's add some triggers. Nobody really was looking. And then, a few days after the triggers were slammed into production, people start going, our data's not right. And now we got to fix it. Real nightmare. Usually they're noticed fairly quickly, but quickly might mean hours, and hours might mean a heck of a lot of foobar data, okay? And data integrity problems are not good. So we have to be really careful. So I was just going to prove the points here. You can see why we got this from that test ID parent 3. It got the data modification identity and at identity 6 as opposed to the real parent ID. The way that we can do that is with scope ident. And if I grab the scope of the identity to be the same as where it's inserting, right, you can see I inserted 4. So then all my new final few rows have the correct parent ID. Again, I'm not here to do a whole bunch of programming stuff. I just wanted to make the point, though, that a lot of developers want to generate the IDs because they don't want to make round trips. And what I'm trying to say is you don't have to make a round trip. You could very easily have in the code to generate a parent, trap that parent ID, insert the rows into the child table. All of that can happen within one batch, and you're good. Okay, and very fast, okay, much more efficient than anything else we've had. And there's some really cool features in SQL that, as of 2005, allow you to do like batch scoped identities. So that's very cool as well. And I'll just point you to a little bit on the books online for scope identity and the outputs. But I wanted to make the point. But I've still got a little bit more on fixing all these problems. So I just wanted to make sure that you knew there is hope for your developers, and it's really not that hard of code to write. So I think a lot of developers have been burned, or they've just been taught to use GUIDs because disk space is cheap, because it's no big deal, right? And remember, I go till 6, okay? Technically, I go till 6, not me just going over till 6, which is likely, but this time I actually have till 6. So, all right, so I did my scope identity. Output, there's an output clause in T-SQL in the books online, so that'll help you as well if you want to do batched kind of scoped identities as well. Okay? Now, you guys have GUIDs, I know that, and I definitely have some good solutions for you. I'm going to give you kind of my series of things that you can do with a whole bunch of links and things that'll help you as well. I'd say number one, first and foremost, because I know you're not going to be running out spending $12,800 on a hard drive, because that's how much some of these enterprise class solid state drives are, is literally $10,000, for a 640 gig, a 1 terabyte drive. They ain't cheap, okay? I totally understand that. Obviously, they can solve some problems, which is, cool, but we might not be able to afford them. And so the first thing, first and foremost, and even if you get them, you still need the maintenance. You really do need the maintenance. You'll definitely get a lot of benefits out of the maintenance. Now, if you are writing the code yourself and it's your architecture, the first question I want you to ask yourself is, do you really need GUIDs? I mean, do you really need GUIDs, or was it the easy solution? Your developers were told it was a good idea, and that was the mantra. I mean, it was just like, when GUIDs came out, it was just like, everybody was all excited, and it's like, now we don't have to deal with identity and all their problems, and everybody went crazy with GUIDs. But I think now people are starting to learn the effects of these GUIDs, and they're starting to realize that, maybe we need GUIDs in some tables, or maybe we need kind of an entry point of a GUID, but then internally in the database we can use an ID, and we can even use that ID in the other tables as foreign keys, and we can start to at least internally move away from the GUIDs, not using them for every single table, and start bringing it down to 1 or 2. And we can move away from the GUIDs being clustered, maybe just even moving to making them non-clustered and clustering on something else, even if you're arbitrarily adding an identity column. Right? It'll make the table a little wider, but it'll make your joins more efficient, it'll make your non-clustered indexes more efficient, and the more non-clustered you have, that will actually really pay off, even in insert speeds, even if the table is a little bit wider because of the identity, although 4 bytes is not massive. Okay? But you might be cutting indexes in half, right? Because you might be taking those GUIDs out and going to integers in the non-clustereds, and across 10 or 12 or 47 indexes, I hope not, but I've seen that. That's huge. I mean, that's literally tens of gigabytes, if not hundreds of gigabytes in some cases of space. So it's huge, okay? So moving to that is really good. So that would be one of the first steps. Clustering key is what I would think of first. Switch, if you can, to a clustering key that doesn't create the fragmentation and that is hopefully as narrow as you can make it to help your non-clustereds be more efficient. I would then try to slowly change the code internally so that all those references, instead of referencing the GUID, even though you're still using it, the internal tables, once you insert with the GUID, right, they take that identity value and they insert that into related tables so that all the joins can be on the integers, not the GUIDs. And I'm telling you, I've done this in a couple of databases, and I've had people that just, it was actually quite funny. We had to take a whole weekend of a system offline on one of the bigger systems that we had to do this on. We did it, and it was like they had their customers, because they're like a website, I'll say, okay? And their customers were calling on Monday going, is something wrong with the database? Everything's really fast. They had customers actually calling them going, are we getting the right information? Is all the data online? Because it's coming back really, I mean, they were shocked. They had customers calling them because the performance was like everywhere better just by cleaning this up over a weekend. Okay? Yes, downtime over a weekend. People weren't happy about that, but we were able to stage it so that it was the wee hours of the nights, and we did it in chunks over the course of the weekend, so we took a hit, but it wasn't all that terribly bad. I think in total about 20 hours. So sleep during the day, but the point, we got it all fixed, and people were like astonished on Monday. The feeling is everywhere in the database. Everything tends to be lightened up by switching to this. Now, if you can't do this, then maintenance is obviously critical, and the infamous phrase, killing it with iron, can maybe help you a lot. And then you also have this problem, and this was actually the problem that we had, and this is why we had to take it offline. They had the problem, the very problematic problem, which is that the clustering key is your primary key, because that you can't just switch, right? The way you have to do this is ideally take the database offline, and the reason why is you're going to be getting rid of keys and indexes, and if you kept the database online, it'd be a nightmare of both data integrity and performance. So you're going to have to find a window, and maybe you'll have to stage it. Do one table on one day and another table on another day, and take a 2-hour window during the least active time of day, and slowly do it over the course of a week. Believe me, the long-term gains will outweigh this downtime, but it might be a real pain in the tush in the interim. But take the database offline, disable your foreign keys, all the keys that go into that primary key, which is clustered. Disable the non-clusters. Don't forget to do this, because if you drop a clustered, all your non-clustereds have to be rebuilt using the heaps RID. If you then turn around and immediately create a clustered, all your non-clustereds are going to get rebuilt a second time. So you absolutely want to disable your non-clustereds on the table where you're dropping your clustered. Then you can drop your clustered primary key. Then you might have to add an identity, right? Then create your new clustered index, create your primary key as non-clustered, enable your non-clustered indexes through rebuilds, and enable your foreign keys with check. And I know you're all looking at that going, oh, I thought it would be easier than that. No, this is the sequence of steps, and it is a real pain in the tush, I agree. One of the things I did recently for the SQL Server Magazine Q&A that Paul and I write is I did a post, and you don't have to be a subscriber to get to these, to our blog posts on the Q&A. I did a blog post that was called Changing the Definition of a Clustered Index, and the code for that actually generates all of the disables and the disabling of the foreign keys, the disables of the non-clustereds, the enabling of the non-clustereds, and the abling of the foreign keys with check, which is very important. Because if you enable foreign keys without the with check option, then your foreign keys won't be trusted, which actually affects join performance and join cardinality. So you really want to make sure that you don't just re-enable a foreign key. That's not good enough. The syntax is bizarre, though. It's with check check foreign key name. It's literally with check check foreign key name. That's how you re-enable a foreign key. It's bizarre. But the code is there, and that'll help you get it right. And so that's why I put that there. Yeah?
Just wondering, if you keep the database offline, can you create a swap?
So that's not a bad idea. So the question was this: if you're going to take the database offline anyway, might it be a good idea to actually create like a secondary copy with the new column, maybe insert select or batch migrate data? I've done that in a couple of cases too. The only real issue is that you're going to keep more data around a little bit longer. I mean, when SQL builds the cluster, they have to duplicate the table, so you're going to need the space anyway. So you could certainly do that and then have kind of both the tables and be analyzing it. You could even be building it potentially while the database is online, depending on the volatility of the existing data. And that might be an acceptable, strategy for you as well, to let you have a little bit more time online, especially again if the data is not overly volatile. And there's cool things you can do too, like you could do things like table diff, to diff a couple of tables, or you could write an outer join to see what rows are a full outer, to see which rows have changed in the two sets. So you could write code to kind of analyze the two tables after you've done it as well. So I mean, there are things you could do. They all just end up taking more time and more resources, but absolutely, they might keep you online longer. Absolutely. Now, once the clustering key is fixed, I mean, you will need maintenance. Obviously, you're going to have fragmentation in your non-clustered index. So maintenance is absolutely really, really important. I've got a couple of slides on maintenance to wrap up the session. So I have a little bit more on this. But you will have fragmentation. There's no doubt about it. Everybody does. You just really don't want the fragmentation in the clustered because it's the hardest to deal with, the hardest to manage, and has the most requirements on it. You might not even be able to do it as an online operation. Okay? So what if you can't change the schema? Okay? What if you cannot change the schema? And I know you guys have a lot of third-party apps. It's not just SharePoint. SharePoint does some things incredibly well, don't get me wrong. It's just this one is a big one, and this one causes people a lot of grief. The most important thing I can tell you, and I'm not sure if I did that one big enough, is maintenance. So I thought I would make it bigger. Okay? Maintenance. No, obviously, I've said this a couple of times, but you should have that no matter what. Okay? The other thing you could do, kill it with iron. Again, big letters, buy a solid state. I mean, if it's that critical and, you really don't want the performance hit, put the maintenance operations into effect, see how they benefit you, and if that's still not helping, you can't re-architect it, so maybe the best thing to do is to throw some better hardware, a bigger machine at it, better, faster hard drives, more memory at a minimum. I mean, if you can give it faster hard drives, then you might not be as I/O bound. If you can give it more memory, you might be able to keep more data in cache. But since it's going to be so much data because of how fragmented it is, ultimately, I still get back to the point where you're going to be I/O bound, so solid states are one of the few things that's going to give you some alleviation of that particular contention. Let me wrap up, and then I'll stay, I promise, for questions, okay? Is there anything that I've said wrong or that you want to? Okay, so I hate to say it, but this really can help. SSDs for the data portion. I hear this all the time. People will say to me, oh, we want solid state for the log. Why? The log is sequential IOs. I mean, yes, maybe if you're really just trying to get even better throughput, but as far as the bang for the buck, it's generally where you have random IOs, not sequential. Now, if you have an L drive as your log drive and you're writing 57 databases logs to the L drive, okay, solid state might be a good idea. Okay, but I generally don't tend to do that if I can avoid that. So, but SSDs for the data portion, more memory, like I said, and that can help reduce your physical I/O by keeping more of that data in cache. But remember, one of the bigger problems is size alone. So you do have to be thinking about that, you know, and just making some of these columns smaller and narrower is going to help you as well. So let me just sum up with fragmentation. I've got like 3 slides and we're done. Okay, so and we're like 5 to 6, so perfect here. But in terms of fragmentation, you guys saw it, waste space on disk, space in memory, space in a backup, right? You do have the ability to use backup compression in standard edition in SQL 2008 R2, which is very cool, okay? So keep that in mind, but that's 2008 R2 standard edition. So that's something that might motivate you for that, not sure. But it wastes time on inserts, especially with splits. It wastes time on updates when there's splits. It wastes time on selects and scans because the table's so much wider than it needed to be because of all the splits. And the IOs are not sequential. So you have lots and lots of problems here. DMDB index physical stats is definitely something you guys need to be using. And you can look at really 3 things. Really, there's only one thing I tend to look at, and that's the average fragmentation in percent. That number should be low. If your table has a GUID as the higher order element of a key, the first column of a key, that usually gets very high very quickly, okay? And that's what you're trying to squash. Page density also suffers, but if you're looking at fragmentation and your fragmentation is creeping up, I promise your page density is going down as well. So, I mean, they're correlated. All you have to look at is average fragmentation, and that tells you enough. If you have fragmentation, and it's not just the number, it's how fast the number increases. You know, if you rebuild on a Sunday, and on Monday you're like 0.01, and on Tuesday you're like 0.02, and on Wednesday you're who cares? But if you rebuild on Saturday, and by Sunday at 10 a.m. you're at, you know, 99% fragmented, which is what happens with a lot of GUIDs, you've done something not quite right. You might have rebuilt with 100% fill factor. So that is the answer to this, is fill factor, fill factor, fill factor. Instead of filling all the pages to 100%, we're going to instead use a fill factor. But we have to remember, if we set our fill factor to 90, that's going to make our tables essentially 10% larger. So we want to come up with a really good number that's high so that we have enough free space, but we don't want to rebuild that frequently. But if you could rebuild frequently, you could go with higher numbers. I mean, 10% is 800 bytes. Right? In a non-clustered index, if the non-clustered index row is only 50, you're talking about, you know, 16 rows. And when they're evenly distributed, that's now hundreds, if not thousands of rows before you start having splitting. So a fill factor in a non-clustered index goes a long way. So that's really cool. So I wouldn't just blindly set everything to like 70%, which I've seen some products and people do, okay? I mean, yes, it'll probably solve a bunch of problems, but it probably wastes too much free space, takes too long to build, and might not be what you really need, okay? So you have to think about that. So how do you set it? Well, somewhere between 1 and 99. Isn't that helpful? I knew you'd love that. Between 1 and 99. No, seriously, it's not a number I can give you, but I would argue more for 80 and 90% than lower numbers. But I have gone to customers, I've set it to 10. Because they can't rebuild very often, they can't change the schema, they've got nothing, they'd rather pre-allocate the space so that they don't have all the problems with splits and they can't go to SSDs. All right, fine, I can do it. You know, you can set that darn fill factor as low as you can if you have to, but I try not to if I can avoid it with more frequent rebuilds, okay? So you're gonna have to estimate it and you're gonna have to see what it does. You're gonna have to see how frequently you're gonna rebuild and how fragmented it becomes, and then you can kind of slowly tweak it, again, for only your 6 or 8 monsters. I'm not talking about every table in your database, just talking about those 6 or 8 ones that are killing you right now. And then once you solve those, all the other stuff is kind of, sure, throw a 90% who cares fill factor at it. You know, and I don't even care, you know? But those 10, 6, 8, 10 monsters, I care. And you have to think about what's causing the fragmentation, and then come up with a number. It's a guesstimate, and then test your guesstimate. Ultimately, that's it. So I'll tell you a little bit about automation, just mostly with links. You can check out the DMDB index physical stats transact SQL reference, and there's an example. It's actually example D. It's called using sysdmdb index physical stats in a script to rebuild or reorganize indexes, but it doesn't set a fill factor, so you might want to do that. I would actually really recommend Ola Hollengren's scripts, which he gives you the T-SQL, so it's just scripts and code that you can play with and tweak, and you can set all sorts of numbers and have this code run regularly and do different things on different days to different tables, which is quite cool. Okay? You could use maintenance plans. I mean, I have mixed feelings on maintenance plans. I'm certainly not going to bash them because they are easy, but you want to be careful to not fall into the, that sounds good. Oh, that does too. And that does too. And then like checking every single box where you clean up free space and you rebuild and you update stats and you end up in worse states than you were before. So if you're going to use maintenance plans, get a good feel for what they're really doing before you implement them. And I would usually create individual jobs for the different types of activities, not one job that does everything every night. That's kind of one of the worst things you can do. So to bring it all together, last slide here, okay? Good design will always scale better than, I know you've heard this statement before, let's just get it done and we'll deal with performance later. How many of you have heard that one before? Yeah, everybody. I always hear that. Scalability does not mean add more indexes. And look who just said that. Indexes are my favorite feature in the world, okay? I wrote the chapter on indexes for the internals book. I absolutely adore indexes, and I would absolutely say that they are the single most important thing you can do in your database for performance. But yet, I see people getting into trouble with this all the time. They add too many indexes, so total nightmare. I think performance and scalability takes three things. You have to know your data. You have to know your workload, okay? But, and this is definitely something we talked a lot about today, you have to know how SQL Server works, because if you don't get a feel for what's going on with those non-clustered keys, then you're going to make decisions that you're not going to understand the repercussions of, and by the time you do, your app's already running and it's not scaling, and now we've got to fix it, and now we have to have downtime, right? So these three things together will allow you to design better databases, okay? No matter what, you definitely need good maintenance, though. I really definitely will end with that. Although I do have one last thing. I forgot to tell you this. Well, of course, I didn't forget to tell you because I have a slide, right? The most important reason not to use a GUID is that there is a year 3400 problem. So you guys may end up running into some trouble, okay? And I do have a quote for that. I'll stay for questions. Thank you very much, and hopefully I'll see some of you on Friday. Fill out your evals. I always forget that. So please fill out your evals. I know it's late, but definitely take a stab at that. We definitely appreciate your comments. Thanks. Yeah.